Hello, my name is Andrea Lopez, a student at Tecnológico de Monterrey in 6th semester of Business Informatics. Today, I will explain you the 2k factorial design by a problem from Montgomery's Design and Analysis Experiment book. I choose the problem 6.8, which says, a bacteriologist is interested in the effects of two different culture media and two different times on the growth of a particular virus. She performs 6 replicates of 2 times 2 design, making the runs in a random order. Analyze the bacterial growth data that follows and draw appropriate conclusions. Analyze the residuals and comment on the model's adequacy. Now, what is a virus? It is a microscopic organism that can replicate only inside the cells of a host organism. Most viruses are so tiny that they are only observable with at least a conventional optical microscope. Viruses infect all types of organisms, including animals and plants, as well as bacteria and archaea. In this problem 6.8, we can see that we have to replicate. So we have to make the sums for all of each data. For example, for the time of 12 hours, we know that we have a total sum of 296. And for the time of 18 hours, we have a total sum of 415. Now we need to make the sum of the culture medium. For the first culture medium, we have a sum of, I think it's 363, and for the second culture media, we have a sum of 348. Now we need to know the total sum of the totals we make. So we're going to sum the totals. In fact, we need to have the same total sum from these two totals and from these two totals. Now we have the levels of factors, where A is equal to 2, and it is the 2 type of culture media. B is equal to, and it is the 2 different times of the growth of a virus. C is equal 3 because of the numbers of runs by hour. N is equal to because it's the number of observations in the data. N is equal to 24 because it's the total runs made from the data. Now we have the NOVA table. The NOVA table is conformed by the sum of the squares, the degrees of freedom, the error, and the F number. For the sum of the squares, we have to make and know the average of each source we have. For example, the average for A, the average for B, and the average for AB. As well, for the AB, we need to know first the sum of the square of each letter, and for each square from 12 and 1, for 12 and 2, for 18 and 1, and 18 and 2, that are these numbers we have here, and the average for each, taking in account the auxiliary table we did before. As we have here, in the sum of the square of A, we have the equation of sum of the square of the totals of the A factors, and there are divider times the levels of factors we have here. As well, we have to rest the sum of the square of the total value we already know divided by the time of numbers of data we have, that it's n. And here we have a total of 590.04, and do the same process for each of the factors we have here. For the total, it's a different equation. We have to make the sum of a square of all the data minus the sum of a square of the total number of all the data between the time of the quantity of numbers we have, in this case 24. The error is calculated by the total minus the sum of A, B, and AB, as we can see here in the equation. For the degrees of freedom, we know that we have to rest from the levels of factor -1. So as we have two levels of factor, for A, it's 2 minus 1, it's 1. For B, the same process, 2 minus 1 is 1, and for AB, it's A times B, so 1 times 1 is equal to 1. For the total, we have a total data of 24 numbers, so we have to take to discount the degrees of freedom from the sources. So 23 minus 3, that is the sum of these sources, we have an error of 20. The MS error, it's calculated by the sum of the squares between the degrees of freedom, in this time between 1 each of the sources. In another hand, the error is calculated by the same time, but it is the sum of the square, 102.16 between 20. So we have a total of 5.10. To know the F number, we have to divide the first source between the error, and we have to do it with every source. Now, to know which number or which source is really significant, we have to verify with the F table. To know these values, we have to make the probability, then the degrees of freedom of the source, in this case 1, and after that the degrees of freedom of the error, in this case is 20. And having a number of 4.35, so like this number is smaller than the F we have already, it's not significant. And for the next F tables, like we have the same degrees of freedom, we have to make the same process. In this case, we have the same value for every source. We know this one is significant because it is smaller than the F table. So we can see that this is the one that really matters. For the normal blood residuals, we have the expected value, observed value, and the residual. The expected value is the average from the table AB. Every value that is between the 12-hour and media 1 has a value of 23.33, and so on with the other values, as we can see in this table. The observed value is a value that we have by the given data. These values have to be ordered by the smaller to the biggest, and with this information we can obtain the residual. The residual is confirmed by the subtraction of the observed value minus the expected. This is how we get all the residuals to make the other steps. After having the residuals, we have to analyze the probability versus the residuals. First, we need to put on our table the place. We have to put the places by the number of data we have. The residuals that we obtained in the last table, we put it right here so we can obtain the probability. But how is the probability obtained? The probability is obtained by the formula of the place minus 1/2 of 1 between or divided by the number of data we have. In this case, we have 24 data, so we have to divide it for 24, and so on. We have to do the same with every data we have. For the table we obtained later, The table we obtained before, we can have the graphic. The graphic for the normal plot residuals is this one. As we can see in the graphic, we have like a linear regression where all the data is going for the same direction. Here, it can explain us that there is no abnormal movement or behavior during that experiment. Now, as we can see, we can obtain the residuals versus expected. The expected values, as I said before, are the values of the average from AB, and the residuals are the values we obtain from the value observed minus expected. For this, we can make the graphic as we can see here, and we can know the movement, but even though there are some spaces between each experiment, we can see that there is no abnormal movement or behavior during the experiment. In conclusion, the growth rate is really affected by the time, in this case the factor B, and by AB, which is the interaction of culture media and the time. We can notice some indications in the process that represents the inequality of variance in the decreasing shape shown in the plot of residuals compared with the predicted. Thank you for your attention. I hope this was useful for you. Have a nice day.